Okay, ladies and gentlemen, this is the second part of Chapter 6, Section 1, and we're talking about other possible solutions besides one solution, besides two lines intersecting at one spot. So the first thing I'd like you to do is to, with these three graphs, 1, 2, and 3, draw them in your notebook and label them with what you think the correct type of solution would be. We've got three options. We've got one solution, no solution, and infinite solution. Okay, take 30 seconds and do that by yourself. All right, so if you said that the first one was no solution, the second one is one solution, and the third one is infinite solutions. Now, that might have been tricky for you to figure out because there's actually two lines there. There's one on top of each other. And so the red line is literally right underneath that blue line. And so you can't see it, but they're on top of each other. They're touching everywhere. So now I'd like you to open that organizer that I gave you yesterday, and we've already filled out when it's best to use. We've already talked about one solution. What I'd like you to fill in now is no solution. So no solution happens when lines are parallel and they do not intersect. And we can draw a quick example of that. And then infinite solutions are when lines are identical and intersect at every point. And again, let's draw a quick example. Let's see here. So here we can do a green line, and then right on top of it, a red line. Hey, I did a pretty good job there. Okay. So let's look at an example. This one's going to be infinite solutions. And so that means we are essentially going to have the same equation. Means every ordered pair on the line is a solution. Now, what you'll notice is we have one line that's already in y equals mx plus b, so we can graph that really easily, starting at 3, rising 2, running 1. Now, the second line here is going to be a little bit trickier. It is not in y equals mx plus b, so we've got a little work to do first. We want to get the y alone. So we're going to subtract 8x from both sides. That gives us negative 4y equals negative 12 minus 8x. Divide everything by a negative 4. And that gives us y equals 3 plus 2x. And so what we're noticing is we've got the same y-intercept and the same slope. So these are the same line. They are on top of each other. Your final answer is infinite solutions. You must write the final answer in words. Let's try another one. This one's no solution. That means that the two lines are going to end up being parallel and that they will never cross. So you notice that both of these are not written in y equals mx plus b, so we got a little bit of work to do first. Let's go ahead and rewrite the first one. Oops. We've got x minus 2y equals 4. So we're going to subtract x from both sides. That gives us negative 2y equals 4 minus x. divide everything by a -2, and that will give us y equals -2 plus, I don't know if you guys remember this, but we're dividing a 1, so that gives us plus 1/2 x. So let's go ahead and graph that one. We're going to start at -2, and we're going to rise 1, run 2. All right, and I like to make those dots really long so you can see where they're going across. All right, let's rework the other one. We're going to subtract x from both sides. We get -2y equals -2 minus x. Dividing everything by a -2, we get y equals 1. And again, there's that invisible 1 plus 1/2 x. So this time we're starting at the y-intercept of 1, rising 1, running 2. Now you're noticing that our slope is the same. We've got two lines that have the exact same slope. That means they are parallel. The final answer is no solution. These lines will never cross. All right. This time I'm not going to tell you what the solution is. It could be no solution, it could be one solution, it could be infinitely many. Give it a try all by yourselves, and then I'll help you. So the first equation we need to rewrite. Subtract x from both sides. We would divide everything by 3. We get y equals 4/3 minus 1/3 x. And then the second equation we need to rewrite, we're going to subtract 1/3 x from both sides. It gives us y equals 1/3, -1/3 x. So I'm sure you guys are thinking this must be really ugly. Well, yeah, it's got some fractions. Let's start with this one right here. Y equals -1/3 x. That has a plus 0 that we can't see. So our y-intercept starts at 0, and we're going down 1 over 3. All right, and then our second graph starts at 4/3. Where is that? Well, you could plug it into your calculator, and you would find out that gives you 1.3 repeating. So approximately right there. And this slope is also going down 1, run 3. Okay, whoops, that one's a little bit off. All right, so what do you notice? Well, if you said that these two lines are parallel, you are on the right track, my friends. We have no solution. Now, some of you might have been able to figure that out without even graphing it. If you notice, they have the exact same slope. When they have the same slope and different intercepts, they will be parallel, and you wouldn't even need to graph it. All right, I brought this question up at the beginning of this video. Is it possible to have exactly two solutions? I'll give you a minute and think about it. Can you have exactly two solutions? Two lines crossing in two places. Well, a line has to be straight. Is there any way two lines could cross in exactly two places? The answer is no. It is not possible. But a lot of people ask me about that, so I want to make sure we talked about it. Okay, so tonight, guys, I would like you to do just 4 problems. You're going to do 17, 19, 21, and 23. Make sure that you determine the number of solutions and name it.